Thank you guys for coming for the presentation. It's my very first thing, so probably just bear with me. Uh, a little about myself. I am working with the PwC Singapore, and uh, I have a few abbreviations attached to my name. And apart from that, I have a few CVs from Adobe, Apple, Amazon, and Google, and those were not XSS. And apart from that, I've been acknowledged by for bug bounty thingy, and I write poems and short stories as well. So what we'll be covering today is about domain name system, the types of DNS-based attacks, data exfiltration using DNS, out-of-bound attacks using SQL injections and XML injections, and we'll have a little thing about DNS messengers, and then DNS exfiltration restrictions, because DNS is only have a fixed string length, and then how a company can uh, use the DNS to better improve their security standards or security postures. So let me take you guys through a story. It should be an interesting one. So a long time ago, there was a victim's computer, and it had a file called password.txt, and it was surprisingly had a malware into it as well. And it was affected by a malware, and what the malware did was it established an outbound connection through it using DNS to the attacker's computer, and then it just transferred the data from one end to the other end. My arrows somehow are they missing into it. So we'll be having a demo for this as well. I'll be demonstrating that. So the motive is to get the password.txt file from a victim's box, and we will be using DNS collaborator because that's an easy setup for me. And then we'll be taking out the password.txt file and getting it to the burp. So carrying on with the demo. Supposing this is a victim's machine, Kali, generally people won't use it, but still, I have created a little shell script which takes in a collaborator address, and so here's my burp collaborator client. I copy the address, I paste it here. Then the file to exfiltrate is password.txt, does something, and let's see what happens. So I get the data sent here in a base64 encoded form, and let's check it out. What is the data that comes to me? This is the end. Since it is base64 encoded, let's check using decoder. Something is missing. Yeah, so the password that I get is hello@123, which was the same as cat password.txt. So this is just a little demonstration of how from one end using a DNS based query one can get it on the other end, and what the command, or what the shell file actually does is that it generally does a NS lookup, and it does an NS lookup to the collaborator client that it provided to, and it takes initial parameters which tells me about how much is the length of the file that we have processed from one end to the other. What is DNS actually? DNS is a domain name system, which is a hierarchical based. Uh, the working of it is like you just ask for a particular DNS name, and it the local domain gives it back to you, telling that this is the when you ask it for an when you provide it with an IP address, it gives you back the domain name for that particular IP address. DNS attacks and organizations. So it's like DNS plays an important role in the organization's posture, because it is like that for accessing the internal or external websites, one needs to have port 53 configured so that the communication between the internal and the application websites can take place. And generally, the security devices that are there all have their ports configured, like port 80, 443, and 53 are generally configured or are open and have been configured like that. And people in like the security monitoring that is done for various companies, it's majorly on HTTP, HTTPS, and such clients, and somehow DNS is missed in those security postures. The risks related to DNS would be cache poisoning, DOS-based attacks, DNS tunneling, and exfiltration. DNS tunneling and exfiltration are two separate entities, and I'll be explaining this to you in a while. What is DNS cache poisoning? DNS cache poisoning is also known as DNS spoofing. What happens is like you are redirected to a particular cache, particularly poisoned cache, which an attacker wants you to visit. So how does that happen? It's like your computer asks your local domain name server for a particular IP address, and then it searches for it internally. And if the cache of the local DNS does not have that particular website, it says, okay, if it doesn't find it, it goes to the ISP and checks for that particular resolution of that particular IP address. But in the same time, if the attacker provides a lot of DNS-based requests to the same local cache, and it updates the cache with the address that the attacker provides, it would result into DNS cache poisoning, and a person can be redirected to a user-controlled site. DDoS-based attacks. DDoS-based attacks are distributed denial of service-based attacks. It is used mainly for disrupting a particular service. A recent attack that took place on Brian Krebs' website was measured to be 363.1 gigs. So it was a pretty major attack. And there are different types of DDoS attacks, which would be reflection attacks and amplification attacks. Reflection attacks are basically the type of attacks in which the user just provides spoofs a particular address and returns the traffic to the victim. And then amplification attacks are the ones in which, like suppose if you provide 10 bytes of data, and the server returns you a big amount of data, like 1,000 bytes of data in that context. So if the server is returning a large amount of data to your short amount of data that it receives, it would result into an amplification kind of an attack. So DNS tunneling is basically facilitates communication, and it is majorly on port 53, and port 53 is, like I have already mentioned, that it is a very rarely monitored port. And then this is one reason that mostly malwares are using command and control based architecture using DNS, so that they can communicate to each other without being detected. Some of the major tools that are there for setting up a DNS kind of environment is Iodine. I guess I pronounced it properly. Then it's DNS Cat 2. Then we have Cobalt Strike and Pickpocket. Iodine is one of the mostly used servers because it configures it because it's easy to configure rather than DNS Cat 2. So the basic difference between DNS tunneling and DNS exfiltration is that DNS tunneling is bidirectional and DNS exfiltration is unidirectional. So it's like when you are tunneling, it's like you are sharing the data between two different computers. But when you're exfiltrating data, it's from like the organization to the attackers, and it's only one way. And DNS tunneling is like it involves a non-standard kind of a protocol. And when you are exfiltrating data using something like SQL attacks or XML attacks, it is known as out-of-bound attacks. So data exfiltration using SQL injections. So this is like in my recent pen test, I was doing a pen test, and what I came across is like it was a blind SQL injection. So in that, like nothing was coming up on the browser, but through the burp interface, I could see this particular line, that unclosed quotation mark after character string, and it was like some kind of an error that was, it was saying incorrect syntax near something. So it somehow I thought that maybe it can be an SQL injection. And when I tried it manually, tried exploiting it, but nothing, I couldn't fetch out a lot. Actually, nothing came up. And then I tried SQL map as well, but using SQL map also I couldn't retrieve any data. So just researching about of how I can get data using SQL injection, I came across out-of-bound attacks, and then I used DNS collaborator, and I made this particular query. This particular query is using master.dbo.xp.tree, which is a known function in SQL, and it is just fetching me the version number of the server that was being used, and the data that came in was something like this. It came in bytes. Like in one request, I got Microsoft, then second SQL, then server, and then the version number. So this is how I got that what was the SQL server that they were using. How can we exfiltrate data using some of the functions that are provided in most of the well-known databases, like SQL Server. In SQL Server, we have some functions like directory, file exist, subdirectory. Directory is basically listing down all the subfolders and folders and subfolders. File exist is used to check if a file particularly exists or it doesn't exist, and the subdirectory is just to basically list down the subfolders. And apart from that, in Oracle we have get host address, which just gives out the IP address, and then UTL HTTP request is like how you can which type of request that you wanted to get or post. Then HTTP URI type, not getclob. Getclob is like one of the character data sets used in major databases like Oracle. And then DBS LDAP.init. LDAP, like if a particular organization is using the LDAP server, and it would be the init procedure can help you initialize the LDAP server that is provided for the communication, and you can retrieve it out of the LDAP server. Uh, Data exfiltration. Then in MySQL, you can have a function like load file, and in Postgres SQL, you can have something like copy, which just copies files from one end to the other end. All of these functions is something that I have not tested, but I have only tested the db tree function in SQL, and supposedly it worked for me at that point of time. Data exfiltration using XML. I am sure everyone is familiar with what XML is. XML is a markup language. Along with HTTP, it helps you to serve uh, uh, data in formatted forms. And if you, just like how you can retrieve data using SQL injections, you can retrieve data using XML injections as well. So when you're using XML for XML injections to retrieve data, you can get the kind of attacks that you can have is like information disclosure, denial of service. You can do SSRF-based attacks and local file reading, just the basic attacks that you can do using XML injections. The same data can be retrieved over DNS, and that will be that will be like data exfiltration. So this was another pen test that I was carrying out, and in that I came across an XML injection. And since I had recently learned about exfiltrating data using DNS, I set up a burp collaborator, and I tried fetching data out of it usingXinclude, and I had got a successful ping from that particular server, so which concluded the fact that it is vulnerable to XML injections, and so I had reported this. And how can one retrieve data using, like how can one set up data using for DNS exfiltration based things? This is magical using burp is through burp collaborator client. I came across this burp collaborator while going through a page by James Kettle. He is working with Google, and he had given a talk about how web cache deception. And while I was reading that particular paper, I came to know that you can, you can have a DNS server set up, and you can get back all the requests that comes in. So using it was then I had learned about burp collaborator client, and using this you don't need uh, a tool like iodine or something. You can just use this to retrieve data from one end to another. So there's this like you just go to the burp. There's this burp collaborator client option, and you can just open it, and then this it already sets up a DNS network for you, and you just copy whatever subdomain it brings it for you, and then you can use it to retrieve data. Like if you are trying to inject data into a particular web application, you can just try putting this whatever domain name that you get through this copy to clipboard. You can just provide it with for each injection points, and if there is a particular vulnerability in that, it will always reflect to you in these parameters. So you can just know that this particular domain or this particular website is vulnerable to DNS interactions. Data exfiltration using SQL map. You can use data exfiltration using SQL map, but while I was doing that particular exploit using SQL injections, it didn't work out for me because what was happening is like only in the burp burp response I was getting that an incorrect syntax is there, but there was nothing that could be fetched, and unless you are using DNS exfiltration kinds where you are seeing the response in the DNS query itself. So DNS Messenger is one of the rats that were developed, that was discovered in 2017, and it was like it was able to bypass all the security configures. It was able to bypass the security mechanisms that was there in place, because it was a in-memory kind of a thing where there was nothing. It was a fileless based rat which didn't have anything on the memory. Whatever it did in the memory rather than having it on the uh, uh, having it on the what to say in the okay, it did most of its thing in the memory rather than on the it was completely fileless, and it used multi-staged PowerShell. So DNS messenger, how they had sent out a lot of phishing emails, and if you send after the phishing emails, if someone had opened that particular thing, uh, uh, it was sending the phishing emails uh, consisted of Microsoft Word-based files, and in that particular thing, they had multiple stages of PowerShell encoded into it, which like the first PowerShell gave a call to second PowerShell, and then that's how the full multi-staged payload could get into the memory and run. Uh, it was they had created a command and control kind of a setup using DNS, and the DNS query consisted of session ID, sequence number, and acknowledgement ID. So this whole thing was provided, and the data could be fetched out using DNS rats, like DNS messenger. So some of the restrictions that are there in DNS is that the maximum of the domain, the name of the domain can have like 253 characters. Apart from that, the subdomain can consist like 63 characters, and it is case insensitive, and it is the requests are like text requests and text requests, DNS records, all that. And how can one use DNS in one's organization to better secure the posture of security is like knowing the organization is like how in the organization what kind of websites does one frequently visit, and what kind of communications happen in the company environment. So using that, one can just, if something fishy is detected, that can be reported. Then top level domains. Top level domains is something like if in the company someone is trying to visit like .tor domains, so that can be restricted and provided not to be used in the company. Then high byte counts would be something like if the DNS queries that are provided have higher byte counts, which would tell the company that something is being retrieved or fetched using DNS queries. Then whitelist the domains, as in if you are aware that what are the domains that the APIs or all the applications in the company are interacting with, they can be whitelisted, so that if some other domain, like in my case, Burp collaborator domain, you cannot fetch using that particular domain. That would be it.
Thank you. Bin ja nicht so. Aber jetzt, ja. Thank you very much. No, keep your microphone on. I'm not letting you off the stage that quickly. Questions? Do we have questions? Come on. He's putting his mic back on, at least one. Yes, thank you.
concerning your ideas on how to really detect and filter this, I think whitelisting domain names is in most environments impractical, because you won't be able to restrict users to use a certain set of domain names. Do you really, because encoding stuff can be, if you the writer of a tool, it can be any encoding. You mentioned base 32. It can be any encoding, and it's really hard to detect abuse. And there may be border cases. Do you have some tips on what to look for? Because as I currently see it, preventing data exfiltration, not just via DNS, is really a hard problem.
To that, I will say is there are multiple there are domains that get since multiple organizations have this threat intelligence kind of a thing. So whenever a domain which is used for phishing, just taking the scenario, like whenever a domain that is used for phishing and it has been blacklisted somewhere, and when you are fetching that particular data to update your organization with it, like if a particular domain which has newly been created and it is used for phishing kind of emails, if you already have that domain in your through threat intelligence that this particular domain is providing phishing emails, you can just blacklist, you can just whitelist it, like that no interaction should be done with this particular domain. So based on that, you can define rules and just configure it.
Yes.
So one comment to the previous question. So what you can do is to set up your internal DNS to not to respond to the external domains, and let your proxies to do resolving. So no internal host would be able to query DNS internally, but web traffic would go through.
Take it to the coffee shop. Take it to coffee. Any further questions? I mean, interesting discussion. I don't want to stop you, but yeah, sure.
To that, I'll say is like there are times that when the proxy is resolving a particular domain, you know, maybe the application is not sending you out the internal information, but the proxy is sending out you like the internal IP address kind of a thing. So that can happen.
One more question. Did you look at entropy calculation of the DNS outgoing traffic, and if you can detect exfil by entropy?
I certainly have no idea about it.
It's probably because you need to encode something, right? So I guess maybe you have a nice chance there.
This was like a small demo, and the script that I had made, it was just a simple base64 encoded thing. So I'm not sure about the entropy.
No problem.
Any further questions? No? Then we have a few minutes left, so you can grab another coffee before the next talk starts. Before you do that, please give another round of applause to Nitish. Thank you very much. Yeah.